The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
All right, so we finished this. Took a little bit longer than I wanted, but we still got it done about roughly 10-2 there the other day. But because of that, there was a couple things I wanted to mention before we were done. And one of them is, as you progress through Excel, I want to make sure you're following syntax. So, and it might be good actually to review it here today after we've had a weekend off to get back fresh on this stuff. So, for these areas, we used a sum function because we had a range of numbers right above that we wanted to add up, and the sum function works great for that. However, I really don't need to use the sum function in these two spots that we have here. So D11 plus D17, where we just added the two subtotals. And then down here, we added the two subtotals plus the one that was standing alone by itself, which was the minority interest. So we just, as you noticed, did not use a sum function. One of the problems that I encounter every semester is as we start going through this, a lot of people start putting everything in a sum function, which is incorrect. You only want to use sum when you really need to use sum, because sum is designed to add up a range of numbers so that you don't have to just keep putting, like in this case, if we didn't use sum, we would have had to put equals D5 plus D6 plus D7, and you can see that it gets very redundant and overwhelming, especially if there was even more numbers. So the sum function is great for summing up a range of numbers like that, but then I get people putting it into regular calculations. So ideally, on these two, I didn't really want you to use a sum function here. Some of you guys did, and some of you did it correctly, and some did not. So I want to explain the correct way to use it if you're going to use it in this situation, and then the incorrect way. Okay, so I could have also done this as equals sum, opening parentheses, and then I could have added the three figures again. Let me switch back here so we're in this view. So equals sum. I'm using the subtotal, 3016, which is cell D25. But if I'm using the sum function, you notice this is the set of rules I'm supposed to follow down here. This is what they call the syntax. There's a comma there. So if I'm going to use another cell reference or another number, ideally we want to use references so that we're flexible. I need to type a comma because it said to type a comma there, so I'm following syntax. And when I do that, syntax actually boldfaces the number 2 that I'm going to enter, which is the minority interest, which is $44. So I just click on that cell, which gives me D28, and then I do another comma. The other subtotal, 11,512, close it. Equals sum D25 comma D28 comma D33, and if I press enter, 14,572 is the result, the same as if we just added it without the sum function up here. That's also correct. It's completely correct if you did it that way. However, even though you get the correct answer, this way is incorrect. So if I go equals sum, opening parentheses, I click on the 3016 in cell D25, and if you typed a operator inside of the sum function, you're violating the syntax or the set of rules. Only in special situations does this apply. I mean, does this actually, is it valid? For this class, it's invalid, so don't put operators inside of a sum function like this. So notice that this is incorrect. I want to emphasize I'm not doing it the correct way here, so don't put the operators inside of the sum function. However, if I press enter, I will get the correct result. So if you do that, you're going to get partial credit. Remember, guys, don't print while I'm lecturing. You can do so at the end. 14,572 is also the correct answer. but it's invalid use of syntax.
I just have some issue with that thing because it says like I didn't put it properly.
Didn't put what properly?
I mean, it says like on the sheet number. I mean, sheet 1 to balance sheet. So it says like tab color of purple. I did it, but it just says like no, I didn't. That's what I take with one mark.
I can take a look at it again, but the one you submitted I don't think had the color on the tab. But if it's there in the submission, we can take a look at it. So if you look at this, think about it. D25 plus D28 plus D33 is actually going to add all up inside here, and it's already added. So it's 14,572. So why do you need the sum function in front of it? Because then you're actually just summing the result, which is 14,572, and returning 14,572. So you're actually creating extra work for the processor or the computer to do another step in the calculation. And besides that, it also leads to other bad habits, such as there's like, we don't really use it in this course, but I do accept it if it's used correctly, but there's a function called product, which you can actually multiply two numbers separated by a comma. And then I get some people using product and then putting plus signs inside of that, or anything, minuses, and it's just not what it's for. So follow the correct syntax. If you do get the correct answer, such as on a test, and you did it with this extra step, you're still going to get partial credit, but it's not full credit because of your violation of syntax. And it is in your textbook. It talks about that too if you want to review it. There's one test question on syntax violation that'll come up in March when we take the Excel test. Other than that, that was the main thing I just wanted to mention. Did anybody have any questions about the layout of this? If I do a file print, should have been centered, fit to one page, so it's 1 by 1. A few of you guys missed minor things like your spell check. Maybe you forgot to do the spell check or something like that, but most of the results were pretty good. All right, no questions then. And then the other thing, just take a quick peek at the homework then that's due on Thursday. PDF files are always kind of slow to open in here for some reason. When you do your header for this, Ali was just asking me about this. This is actually a funny situation because the file name is debit card and the sheet name is also debit card, so it's actually going to be in there twice on 2 lines in the middle of your header, but as we proceed through the course there'll be different names. Just kind of briefly looking at this, same things that we did on the lab where you have to change the sheet name from sheet 1 to debit card, change the tab color to yellow like we did purple on the lab assignment. Type over some text, so replace some text with something else. Change column widths like we did on the lab. Step F, you're keying in the information shown on page 2 of this handout. There's 2 screenshots there. The one is the information I want you to type in, and then the other one is the resulting information when you're all done. You're going to type in a formula. It tells you pretty much what to do here as long as you follow the steps closely. You're going to create what's called a running total. So you're taking your balance, adding any expenses, subtracting any deposits, and then resulting in the new balance. And this is I like this assignment. It's a strong assignment to understand how Excel works because you're actually, you're adding, I should say, subtracting the expense and then adding the deposit. And even though there's no entry in the deposit, because this sheet is, for example, for June, And if I reuse it for July, maybe on the July sheet, that cell has an entry in it. So I want to make it flexible for all occurrences, not just for this occasion. So you are going to use that blank cell, and it tells you that there. It says even though E4 is currently blank, so make sure to include it. You're going to fill it down like we did on the assignment where we can fill formulas. We did it across on the assignment in class, and this one's down. So you're using that fill handle, which is a copy tool. You're inserting a row. We inserted some rows on lab. You are figuring out your own formula using a sum function to calculate the values above. Just make sure to include all values and potential values. Cell reference. One thing we didn't do on the lab's insert a comment, so I'm going to have you explore with that. Your textbook assignments have you do that. Like on the lab accounting format, you're also going to experiment with the short date format, which we didn't do on the lab. The merge and center that we did some fill color, so you're going to do fill color, do some borders, work with your page layout, scale to fit, save the workbook. This one's not landscaped. When you turn it in, pretty much everything from now on out is going to be landscaped in Excel because we do want to turn things on their side to fit more data in there. This data just happens to fit in a portrait format. So I'm actually looking for this in the regular format, the portrait format, but if you did already landscape it, I usually accept it because it's something that's commonly performed with Excel. You're printing the worksheet normally, and then you're going to switch to formulas view using that control grave accent key combination. Print the worksheet again with the formulas showing. Switch back so you're displaying without the formulas. Click in cell A1 and save it and submit to the Dropbox. Both the regular printout and the formula sheet should be stapled behind the Project 1 sheet and submitted Thursday. And did anybody miss grabbing one of these Excel Project 1 sheets the other day? A couple left. Got them? Any questions on that so far? Clear on what we got to do? All right. Everybody's good? Sorry?
Did you say you got to print out the layout file?
You got to print out what?
The layout file. Or is it normal?
Well, it's the normal versus layout is just the view on the screen. As far as the printout goes, you're going to print the regular way. If I just give you an example here, I'll go back to our lab that we had. So you would print just like that with the numbers in there after you've put your formulas, and then you're going to do the control grave accent so that your formulas show, and then you're going to print again. The formulas printout is much smaller. It should, because you do the fit to page, it should still fit to one page, but it's going to be a lot smaller, so don't worry about that because it has to accommodate for the longer formulas. And then, question, Kyle? You had mentioned the date. When you switch to formulas view on your Excel Project 1, where you put the dates in, you're going to actually see numbers instead of dates. And that's because the numbers are actually the number of days since January 1 of, I always forget, it's either 1900 or 1901. Since the beginning of the 20th century, computers were implemented in the 20th century. And so they set a starting date actually originally of 1980 on some of them. And then when they switched to the 4-character format, there's no computers that existed before 1900, so they just set 1900 as the beginning date and then counted a bunch of numbers from that point to that point. And therefore, as we move through the unit, on one of your homework assignments in My IT Lab, you have to subtract a date from a date. And if you see it in formulas view, it makes more sense because it's just a number from a number. So if today is February 26th and I'm subtracting from Sunday, February 24th, I would have the result of 2 or 2 days. It's kind of cool to know. All right. Back to learning about internet and networking, or networking and internet. So it'd be this study guide, Networking Internet. I got a lot left if anybody needs one. A lot left. I don't know how I got this many left. I think I printed too many or something happened. You guys should have the first 6 answered, right? We left off on 7. Just to get us back in the swing of things, number 6. We were talking about the 7 layers of the Open Systems Interconnection Model, or the OSI model. In this class, we don't care about all the details in this. We do care about a few things in it, however. The application layer was where the human being sat, so I think it was question number 6. Remember, we answered that the application layer is associated with the user or the human. And that's pretty evident from this diagram here, because you can see the people sitting there at the top of these stacks. Especially for you guys that missed the other day, that there's a set of rules that we have to follow on a data transmission. The user here sends a message to the other user. He has to go through a whole sequence of events, go through the physical link over the internet, and then get received by the other end. You guys keep it down in the back a little bit here. It's kind of okay. All right, so physical layer at the bottom is associated with the computer. Everything else in between is getting it from the human being to the computer, and getting it from the computer to the human being, so that humans can understand it and computers can understand it, depending on which way you're going. I think I left off on this slide here, didn't I think. So I'm going to pick up here. You have wired or wireless medium, as we started to talk about at the beginning of this presentation, and I showed you wired and wireless transmissions taking place over old telecommunications technology, very old. Remember, we did the telegraph sounder and the spark gap transmitter. Those same type of idealisms relate to what we do today with computers, but instead of sending Morse code, we're sending bits over the copper wire, or in the case of that last one, shards of glass. So twisted pair cable, the one on the left, is the same type of cabling that we have in the classroom here that's running into the back of the machine. It's the blue wire. I see they're blue in there. run into the back of the machine. Actually, yours is gray, so gray or blue. Sometimes they're yellow. And then when I'm talking about the color, it's just the casing. In this case, it's gray. And Category 5 or Category 6 cabling has been used for years as a networking standard. Besides that, the other two, the black one is why they call cable television because it's got a really hard copper wire running through a pretty good encasement so that there's no data interference, or at least it's hopefully preventable. It's hard to cut through those. And then you have fiber optic cable, which is very expensive because it's glass instead of copper wire. And this is what is, or I shouldn't say what is, but it's a good portion of why our data transmission rates are increasing with our cell phones today. As they add more fiber optics, you get a faster data transmission rate. So the more of the backbone or the more of your area has fiber optics, the faster speeds that you're going to get. So there's always a wired component to go with the wireless component, the wireless medium. If we look at that, we have point distribution methodologies. So you got those cell towers that you see as you drive along. 3G, 4G. 3G is kind of like outdated now. A few people got some older cell phones that can only run on 3G still. 4G is what most people have, or 4G LTE. And then we're progressing towards 5G now. You're starting to hear 5G in the news. Also, there's local wireless, so Wi-Fi. So once I connect to my cable provider or whatever internet service provider I have in my home, I can also then spew forth Wi-Fi around my home and connect wirelessly, connect my devices wirelessly to that. Bluetooth is also in the localized category. It's even more localized. It's just right around your own body or your own vehicle. Infrared, when I send a data transmission to actually to this machine here, so I can advance the projection device, I'm sending an infrared beam or command. And radio frequency ID is a little bit similar to your flash drive where you have a low power chip. It's always in a low power state, and instead of barcodes, you can scan boxes with RFID chips on the particular items, and then you can get a really quick idea, for instance, of what your inventory is. That's also like a very localized area of wireless. Satellite, you got GPS systems, for instance, that our cars use, or we just use in general nowadays sometimes with our phone for location. And also we can get satellite internet if we're out in the country. So the question here on the study guide says, what is 4G LTE? Actually, I'm going to put it in order here. Since we're starting to talk about 5G, I'll put that up there too. This is the evolution of our cell phone speeds. Wasn't so long ago, a decade ago or less, we were operating at 2G and then we went to 3G. Now we're at 4G LTE, which is equal to almost 4G, is the simple way to put it. So that's what 4G LTE is. I believe it stands for long-term evolution. And it's a speed somewhere between 3G and 4G, but it's getting close to 4G speeds, what is considered a full 4G speed. This is mainly what we're operating on right now. I would imagine we might, when we go to 5G, they might have like something that's almost 5G too, because it just takes a while for that technology to get to that point or that standard, because these are standards that they set with a certain speed, and then they may not be able to quite meet them, and then they give it a term like 4G LTE or something. And then if we look at the rest of the question, differentiate between 3G, 4G, and Wi-Fi. So they call it cellular for a reason, because there's an idea about cells. Something like that. Anyways, there's a couple cells together. And in those cells we have cell towers, and I'm just going to keep it simple here. I'm not a genius on how all this stuff works. I'm not in the industry, but you got cell towers in each cell. And let's say you're on your cell phone having a conversation as you're driving down the road. You're going in this direction. You pass through this area, and your cell phone connects to this tower. As you start to get over here, it jumps to this one. So it connects to the cell that you're in at the moment, and there's multiple towers in each cell, and of course the bigger the population, the more there are. And you get way out in the country somewhere sometimes, and they've only got a couple, and you might get out of range of even one, and you got no connection. So you're stuck, and we've probably all had that happen to us a few times. And it's kind of like, around the city, I'm used to having pretty good connectivity. Even in my area, I live in Lapeer, and even in my area, I got pretty good connection unless I hit a few dead spots in some really outreaching areas. But you go up north, I've had people say, I went up north to this spot and we got nothing. It's because they don't have any, nothing within range as we drive through here like this. So this is the point distribution method. So I'm going to say, 3G or 4G equals point distribution, the cell towers. And one of the reasons I showed you the radio earlier is essentially it's radio technology. Whereas Wi-Fi is localized. So remember, a LAN is like a college campus or building. So let's say I take South Campus here, C building. What's the one over here, B? I'm not good with my buildings over here. I'll just draw some buildings, I guess. So I got some buildings. I know J is over here, the library, so I got J. And each of these buildings, which is part of the local area network for the college, in each of these buildings, they put routers in here that send out the Wi-Fi. So I got a little Wi-Fi router in here spewing forth Wi-Fi, and it might be at different locations in the building, at different floors in the building. There's a science to it where they have to put them all in the right spot. They have to take into account what walls are brick, which walls are not brick. So they come up with a plan to get this so we have hopefully campus-wide Wi-Fi, so each building has its Wi-Fi spewing forth. And the idea is if you want campus-wide Wi-Fi, you've got to get it so it overlaps in the courtyard as well and so forth. If it doesn't overlap, you got a gap out there somewhere, so you might lose your Wi-Fi connectivity on your device as you're sitting out there somewhere. But all this is spewing forth, so Wi-Fi is local. It's a local technology, or LAN, local area network technology. Same thing at your home. You get your internet service provider to provide you the connection. And then once you have it, you can have a wireless router in your home and spew forth the Wi-Fi and connect all your other devices, and it's localized. Somebody brought up a good question in the fall. They said, what about this new Wi-Fi where it's like available everywhere? You're still getting it through a localized connection because it has to be localized to that particular spot. So it's still in the LAN technology. So there's your differentiation on question number 7. Somewhat similarly, question number 8 here says differentiate between a hotspot and a mobile hotspot. This is how Wi-Fi works, as we were just talking about localized. We have a distribution system, so this is connecting back to the backbone of the internet here. We have our Wi-Fi access point, and then we have our, that'd be our wireless router. And then we have our receiving station, which is usually not a PC that looks like the 1980s like that, or 90s. It would be your laptop or your phone, for instance. If you're at the campus here, they're providing free Wi-Fi, or McDonald's, any coffee shop usually. However, you can also have your own connection on your cell phone, such as your 4G connection, and a lot of phones allow you to convert that into a wireless transmitter. Hotspot, or a mobile hotspot in that case they call it.
Usually they have that for a price.
Exactly, that's why I got the $sign up there. So that's one of your biggest differences between a hotspot and a mobile hotspot. Hotspot is free Wi-Fi, and a mobile hotspot is you're actually paying for your data plan, and then you can use your device as a mobile or moving hotspot. So if you're using your smartphone and you have other devices connected to it, they call that tethering. That's a term called tethering. It's an important term to know. If you hear that, it's not on my study guide. Sometimes I do mention the tethering because we're going to watch a video. In some cases, I think this video this semester I don't have the tethering aspect on there, but some cases they have a bit of a tethering mention on some of the videos that you'll see in a commercial. All of this stuff operates on the electromagnetic spectrum. Wi-Fi and cell phones operate in the microwave range. So if we take a look at what the electromagnetic spectrum is, it's kind of sometimes hard to wrap your head around. It is for me sometimes too. Trying to understand our physical world is not the easiest thing. When you start thinking in terms of science and such as Albert Einstein, things that he came up with. Like we use these cellular devices and radio and everything every day, and we just kind of take it for granted. Like, how does this stuff work? Well, like everything in our room here is in the visible light spectrum, so we can see this slide with the color. We can see each other. We can manipulate around our physical environment. Obviously, if we have less light at night, we can't see as well. We can't see color. So visible light is actually part of the electromagnetic spectrum, and it's a wavelength that the human eye can interpret. Outside of that, on both sides, we have something we hear about quite frequently, the infrared radiation and the ultraviolet radiation. So if you go out to the beach, and you're sitting there, you sit there too long, you could get too much exposure to ultraviolet. It's bad for your skin. As you move up this level towards X-rays, they say that you're not supposed to have a ton of X-rays taken because it can be bad for your health. Gamma rays are cosmic explosions or nuclear explosions essentially, so extremely dangerous, would kill us. They're taking place in space all the time. Going back this way, we do use the infrared spectrum, again like to send commands with a device such as a remote control, garage door opener. Microwaves is where Wi-Fi and cell phones operate. As we move to a lower frequency, we get back to radio. And then as we move back this way, you're actually moving out of the range that we use and into like the range that whales use in the ocean. Very low frequency waves. I took a slice of the radio spectrum here because it's kind of easy to relate to, because if you listen to the radio, AM and FM broadcast is actually on the spectrum. AM broadcast is a lower strength wave than FM is, and then you start moving over here into microwaves, as you can see, and infrared over to the visible. Once we go to a very, very low frequency, we're out of the audible range too, by the way. Couple of videos to watch. This first one, we watched the first three. I think we ended class on number 3, the 3 basic types of wireless. electromagnetic spectrum, when it comes to electronic communication signals, what does the term frequency mean and what is it measured in? You may already have the answer because I had you write that down during lecture. If you didn't catch it, it'll be in the video here, so it's just reinforcement. This video is from NASA, so our objective in a computer course is to understand what these devices or how these devices are using the electromagnetic spectrum.
Answer to number 3.
There's three basic types of wireless internet. The point distribution, I think he actually called it the Wi-Fi, but it would be the local or the LAN, and then your satellite.
Very good.
Yep. So it will get very scientific, but I'm just gonna let us watch it here. It's a good learning tool, and they do go back and mention connectivity through satellite at the end. So. One of those old-fashioned, typical classroom presentations here, created by NASA.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billions of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
So making sure you caught that. Frequency means
Well, two things. Frequency is the amount of waves per second.
correct.
And what I was gonna say about when they showed the sun in different light, they have an exhibit of that at the Michigan Science Center, where it can go all the way to gamma rays.
Where's the Michigan Science Center at?
Detroit.
Okay.
It used to be the Detroit Science Center before it got bought out by the city.
Where's it located at? Like what streets?
Woodward, I think.
Woodward?
It's right next door to Charles H. Wright Museum.
Okay.
Thank you.
So, yes, it's the number of waves that pass a given point within a second, and it's measured in hertz, they said, which is the name of that guy that was responsible for those wireless transmissions. At least he has his name applied to the speed at which this takes place. The next video is a short commercial. I'm going to pause it to read the fine print. T-Mobile, it's a recent commercial. According to the fine print in the video, during what T-Mobile Essentials Plan customers may notice speeds lower than other customers, and further speed reduction may occur to users at the blank gigabyte threshold. These first two blanks are actually right in the fine print, and then this process is called, and I'll give you the name of that.
Yeah, I've definitely seen that with every T-Mobile commercial, even today.
Down at the bottom.
Kick off the new year with a new iPhone included from T-Mobile. The amazing iPhone XR is perfect for all those New Year, New You selfies. And only T-Mobile has unlimited with iPhone XR included for just $40. So get the iPhone you love most from the most loved in wireless. Bring your family to T-Mobile and get the amazing iPhone.
Okay, so there's our fine print. After the first sentence, it says, during congestion, the T-Mobile Essentials customers may notice speeds lower than other customers. So congestion is the first answer. Then for B, and further reduction if using greater than 50 gigabytes per month. So 50 is the answer for the first part of B. Further speed reduction may occur to users at the 50 gigabyte threshold, they call it. That's a monthly threshold. And that process is not up there, but it's called throttling. Who said that? Thank you. Yeah, throttling. And the reason that I'm showing this is so that when you guys go out and decide on a cell phone plan, these might be strong things to consider besides just the cost of the phone and what they're giving you.
Yeah, my folks use Sprint. That's the network my dad uses it for.
Sprint.
He works for DTE Energy.
I live out in Lapeer, and I could not get an internet connection through cable out there because I'm too far out, and satellite I didn't want to pay for and deal with all that. So I had to wait a few years, but about 10 or 11 years ago, I got the 3G connection, I think it was, through Sprint, and Sprint was an excellent provider in my area, so my family's been on it. However, I just recently switched my internet to AT&T because they had a better deal.
Yeah, I have AT&T internet too.
Do you?
I hate them.
We do have some connectivity problems with them, more than I had with Sprint, but the deal was just crazily better.
And we had a lot more satisfaction than with Comcast.
Okay.
That major power outage that we had before 2010, we had to wait an extra 2 months for Comcast to come out and fix our wireless router.
Wow.
Yeah.
You talking about that grid outage back in 2003?
Yeah.
Okay.
And after we had a bit of an argument with them, Comcast sent us a pretty offensive letter. That's when we decided to drop them like a hot tamale.
I don't blame you when you have troubles with a company like that. So yeah, I mean, interestingly, now I have done a study sometimes in class and get feedback from all you guys on what devices you're using. This semester I'm not going to do that, but think about it. Like think about the different plans that are out there. You might be surprised that you're overpaying a lot. Like I've noticed that I'm overpaying on stuff, and sometimes just out of the fact I'm busy all the time, I can't get off that plan right away. But if you get some time and you see something and you're willing to take the risk, like be careful, because again, like I switched to AT&T, I think I did lose a little bit of reliability from the Sprint connection that I had. But I'm overall more happy with it because what I'm giving up, it's only a few glitches, and I'm getting a lot more data for the money that I'm paying. Back to Sprint? Really? You work at a Sprint store? Yeah, I went into Sprint and they were like, yeah, we can't match what AT&T's giving you. So I switched about a year ago.
Did you already go over question 4 in a 5A? I missed that.
4A was the frequency, the waves. Remember the waves per second? Number of waves that pass a given point in 1 second is the frequency. It's measured in hertz. This video here, during congestion, that's actually still on the screen here, during congestion. Essentials customers notice speeds lower than others, and further reduction if using greater than 50 gigabytes a month. That's your threshold. Yep.
And when they say congestion, it's when there's a lot of other users that are getting data at the same time.
Peak times of the day, it's definitely congestion.
Like if you've been in a concert and you've been trying to use your phone and it gets slow, that's congestion.
Mm-hmm. Just like rush hour, if you're thinking cars. Okay, so these next 3 questions are regarding the internet lecture, and then there's a few internet research tools. Just so you guys kind of know where we're at too, like a lot of times I typically start this internet lecture at the start of today or towards the start of the day, so I'm a little behind. But we do have kind kind of like a day where we can catch up next Tuesday. And part of the reason we're behind is because I did that Excel assignment where we did the amortization, which I think was important. So no big deal. If we don't finish this today, we'll resume again on Tuesday. But this is the beginning of the second part of the technology topics for the unit. I like to get these done kind of early in the unit, and then we can focus completely on Excel, because Excel gets kind of tough for people, and you can just set your mind to that after we get through this. So question number 9. The internet is a network of networks, the largest network in the world. Leave yourself enough room to answer the web. So maybe put the internet on one line. In fact, this is a kind of a unique lecture because I do a lot of comparison between the internet and the web. Questions 9, 11, 12, and 13 are basically all comparisons. In 9, 11, and 12, you're actually comparing the internet to the web. The first part of the lecture deals with internet, so we'll answer like the first part of those questions, and then we'll come back to them. So this is the original internet. The ARPANET in 1969 connected 4 universities out west.
DARPA is the Defense and Research Projects Association of the United States military.
Yeah, so if you had
the idea for the internet was to create a way to share information in the worst case scenario, which at that time was thermonuclear war with the Soviet Union.
Traditionally what I was taught, yes. Correct.
Well, it did make sense since Russia and the U.S. were bitter rivals, especially with Khrushchev.
So from 1969 until now, that's kind of a visual on worldwide internet now, of course. ARPANET did start earlier in the 60s, but it became official in 1969. The Advanced Research Projects Agency was the beginnings, as you mentioned. Depending on who you talk to, now if you talk to Chris back there, he's got the traditional training that I had. After World War II, our Defense Department noticed vulnerabilities here in the United States that the Germans could have exploited. So they first implemented the freeway system in the 1950s so that we could get troops across the country faster on the roads and made good road systems for us. So that's one of the number one things. Then they also decided that communications had to improve. So they came up with this idea to connect research computers. And if I kind of draw this out, it kind of looks like a bunch of computers being connected together. There was 4 there, but let's say we keep adding to them. And the idea is that we don't just house information at 1 or 2 locations where a bomb could be dropped and knock the one area out. We can transmit data quickly, and hopefully we're storing it at multiple locations, so we got all this going on, and we connect everything together, and hopefully we become close to invulnerable as far as information sharing goes. So that was...
The connections between all of these different points makes what we now refer to as a web.
Correct, but I don't want to get anybody confused on what the World Wide Web is yet. But is correct.
But the idea of the web is it's connecting to everything.
Just like a spider web.
Like a spider web. That's where the term comes from.
Correct.
Kind of like how when they say a bug in the system, it was when there was a moth found in a supercomputer.
So yes, the military.
True story, people. True story.
It is a true story. So the military is the U.S. Department of Defense was supposedly involved in this. There are some and I'm not sure if they're, telling the truth or what, but there's some people that were involved in this project that came out in some interviews actually in like 2014, 2015, and they were refuting that the military was involved as much as everybody says it was. They were like, no, we were simply more interested in connecting research computers. So there's another side to the story that I heard recently. Whatever you want to believe there, I guess. But I think the military was involved to a certain degree, for sure.
Yeah, the concept of this information did come from DARPA, which is a military
Exactly.
contractor.
That's why I have a hard
There's
time.
There's no question that the military was involved because they're basically what you would call the New Manhattan Project was involved in that.
After the initial ARPANET, it expanded, and the National Science Foundation wanted to get involved with these research computers. They were like, this is a great way to share research. So the network expanded. We don't care about all the details, but I'll show a video where it shows kind of some of the quick expansion globally. Schools then got involved because now you got all these science foundations on there and stuff and science research going on, so schools want to get involved. And then eventually businesses wanted to get involved, of course, too. And Al Gore, the vice president in the early 90s, signed some paperwork so that businesses could then access this network of networks called the Internet. And after that, it blossomed, and we have what we have today with all the visuals, all the color, the things that we like to go out and surf on the web. We have e-commerce where we can buy things. So businesses really quickly expanded the web by putting the web out into the market. Time-wise, 1969, NSFNet 1970s, schools 1980s, businesses 1990s. It was like a decade by decade process. One of the second parts there of question 9, nobody owns the Internet. The Internet's not owned by anyone. However, the backbone of the Internet, which are the main Internet routes, are constructed and maintained by major telecommunications companies. AT&T is one of those. So you could argue that they own it, but they don't, because government agencies would get involved, is the premise, if they tried to put their foot down and say that we own this and we're going to block something, and they'd be like, we're just going to take it over, give it to another company.
One of the things that I use in order to make the Internet not owned by anyone make more sense is the way I see inter in the Internet is short for international, that everybody isn't allowed to it. Whenever a nation says that they own certain information, it is accessible by anyone. Kind of like how the ISS is not owned by the US, it's the International Space Station. Meaning that we don't own it. While we did do a great deal of work, all nations with space programs put it together so that it would be owned by the entire world.
Mm-hmm.
In this case, we made the Internet so that it could be used by everyone.
The first part of question 12. TCP/IP stands for Transmission Control Protocol / Internet Protocol. There's actually two protocols that are put together as a suite of protocols. The responsibility of this suite of protocols is to govern Internet transmissions. They're the standard means of communication over the Internet. So just like we learned Unicode was the standard means to, if you type a letter to somebody and you send it, that it's readable at the other end. We have to have a standard for the actual characters we're using, but not only that, we have to have a standard means of communication. Part of the ideal with this is to TCP/IP breaks things into packets or small chunks of data ready to travel the internet. So the first part of question 12, TCP/IP, that's what it stands for, governs internet transmissions. It's a standard means of communication. We'll look at the packets some more on the video. A router is a device which forwards data packets along networks, and that's question number 10. Sorry for skipping around on you a little bit here, but router forwards data packets along networks. And so, if I look at that image that's down here, this is an example. PC Internet Client A wants to send a message to PC Internet Client B, and they send the message out, and it hits a router which says, does this message belong to me? No, send it forward. Does this belong to me? No, send it forward. Every time it hits a router, this is called a hop, and a bunch of hops take place, and then it's received at the other end eventually. Example, live example. So I go down to Cortana here, and I'm just going to type in CMD to get to my command prompt, where we briefly explored what a DOS prompt looks like versus a GUI. And I'm going to type in a networking command called traceRT, which stands for trace route. Let's trace the route to www.google.com because that's a place we go every day, or a lot of days. I'm going to press enter, and it says, okay, I'm tracing the route to Google, and it gives me an IP address, which we're going to talk about here shortly. It's going to trace the route over a maximum of 30 hops, and it took 10 hops to get there. The first 2 hops were internal IP addresses here at the college, and then it jumps out to the Macomb Community College MISNet. It goes to the external IP, it gets out to the real world, and then it jumps out to, I believe the CHI is someplace in Chicago or something like that. I could be wrong on that, but eventually it bounces across all these hops here that we see, and it gets to the 172.217.5.4, which is what Google is here today. And once it gets to that router, which would be assimilated to this one, says, yes, this is mine, so bring it in. So it's just like a mailing address at your house. When you mail, or somebody mails you some mail and it's addressed to you, it has to go to your city, and it might have to come across countries or across the country, a bunch of states. And the different post offices have to go, is this mine? No. And some of these are centralized data centers. So just like the post office might have a really centralized center, maybe like in New York City or Chicago, same thing here. It goes to a big one, and then it eventually gets back down to a local area. So looking at the rest of this slide here, an IP address is a unique number for each internet station, and that's the first part of question 11. .197.169.73.63, or the Google one that we just saw, those are both good examples of external IP addresses. We also saw some internal IP addresses on those hops that start with a 10. If you see a 10, it's a reserved area that multiple companies can use. So Macomb can use it, another company here in the metro area can use it, another area can use it. So everybody's got like a unique external IP, but inside the company you can reuse these IP addresses. So, for instance, the one that I typed out here was actually the IP address to a printer one time that I just took as an example. So the IP addresses can represent your computer, the one you're sitting at, the one I'm sitting at, the printer in the classroom, and it also can represent a web address. A website that we go to has a unique IP address. So IP address, unique number for each internet station, and it looks like that 4 numbers. They also refer those as octets. 4 numbers, which are called octets, separated by dots. There's 3 dots separating them. And that's in IP version 4, which means there's 4 numbers. A little bit simpler thing that we see every day, a term to know. It's not on your study guide. It's ISP. So if somebody says, hey, who's your ISP? It's just your internet service provider they're referring to. It's just an acronym. Businesses and individuals access the internet through an ISP. So Macomb's got its own ISP. You guys have your own ISP to get out to the real world. Common types include cable. Locally, you have your Wi-Fi. The reason I put this up here is if you go to Macomb or a coffee shop or something, you can get on the internet for free with Wi-Fi locally. That's just not maybe your general solution. 3G, 4G, satellite. The World Wide Web now. So I'm gonna start comparing these now. So answering the second part of question 9 there, it says the difference between the internet and the web. This is the definition of the web. It's a subset of the internet, and it's actually a system for the publication of digitized information through the internet. So one of our biggest goals today is to differentiate between the internet and the web. I've got a couple of pictures up here that are hopefully supposed to help us. The internet has main services, they call it, and this is a bubble graph of those main services. The largest bubble is the www, the World Wide Web, which is one reason why the web and the internet are sometimes considered the same thing, because the World Wide Web is the largest internet main service. And also because of what Chris said earlier, the internet, when drawn out, is essentially a web, so that's where the term comes from. Email, as you can see, is also a large internet main service, and there's other services here such as file transfer protocol. This is a service that I have used to transmit bank data. When I worked at the bank, I was receiving FTP transmissions for company payroll. When I worked at the college, I was sending the college payroll out to the bank, so I worked on both ends of it. Instant messaging is on here, chat. Couple things, just examples. Also, the other image over here, when you see http://www, www stands for the World Wide Web. So that's a World Wide Web website. However, you can go to a website that doesn't have www and it's still considered a www site. It's just that this kind of clarifies, hey, this is why this came into being. A guy named Tim Berners-Lee was responsible for creating the World Wide Web. He worked for a company called CERN. 1991 was the year that the web was officially released. So, we're not in a history class, but this is one timeline I want you to know. We talked about the internet was invented or became public in 1969. The web became public in 1991, so you have a 22-year gap there. The web is a subset of the internet, so therefore on your quiz you should remember the internet came first and then the web. Second part of question 11, we saw that an IP address was that unique identifier with the 4 octets. A uniform resource locator is a URL, or a URL is a uniform resource locator. And it breaks down like this. You have your web protocol standard. You then have your web server / domain name. In this case, we have a news site / showbiz, which is a folder name, / movies, a document name and file name extension. We're kind of pounding through all the answers here. So the second part of number 12 said to compare the TCP/IP suite to the HTTP protocol. The HTTP protocol stands for Hypertext Transfer Protocol, and it's responsible for web servers to web browsers communication. So that's the second part of 12. TCP/IP is responsible for the internet transmissions. It's a standard for internet transmissions. HTTP protocol responsible for communication between web servers and web browsers. Specifically, the URL is also sometimes referred to as the fully qualified domain name. You don't have to know that. I just threw it in there. It's just like a file path. So when we're storing files on our drive, we have these paths that we have talked about with Windows. Same type of idea on a web server. You have a file name and extension. The HTM stands for Hypertext Markup Language, which is a basic web page. To take a look at this visually, I think visuals help. You know, maybe not, but I'm going to try here. This helps me a lot. So I'm going to go back to the networking presentation and remind you about the stack here, which is why I actually gave you this stack. TCP/IP is responsible for internet transmissions, and it works here in the transport and network layer. HTTP is up here at the user's level, and that's why you see it in your web address when you type it. HTTP, you're using an application, so it's up here with the people. And the next slide that I had showing this for you guys too on the previous one. If we look at some of the protocols or rules that are in each part of the stack, you see HTTP is right there at the application layer. TCP is at the transport layer, and IP is at the network layer. So your internet transmissions are a lower level in the stack here versus the HTTP. I think that's one of the toughest things to memorize for this coming quiz. When you see .com, .edu, .gov, .int, these are the meanings. These are called top-level domains. .com means commercial originally. It's also now considered an international or any international website. Edu, macomb.edu is educational.
Another important thing to remember is certain .coms will have either .com or .co and then and then an abbreviation for the nation that it's for. Like if you're doing a website in England, it's .co.uk for United Kingdom.
Correct. In Canada, CA. And we used to have a standard of US at the end of some of ours, which a few sites still do have. In fact, Oakland College that I work at actually had a US at the end when I first started working there over 20 years ago. But they've changed it to the modern standard of .edu. So you will see stuff that they haven't actually gone out and changed it. They still kept the same one. So stuff is kind of willy-nilly out there, but they try to categorize it. IRS.gov, Michigan.gov, of course, your government websites for the nation and locally. Military.mil.net is something they squeezed in there. I guess they couldn't figure out where these certain ones should go, so they just put a .net. .org stands for a miscellaneous organization, or originally a nonprofit organization. In fact, when we see commercial up here, this means for profit, and .org means not for profit. That was the original intent. So, I can't squeeze everything onto these study guides, but this is important, and I've had a lot of people miss this. The top level domain, if I go back here, the top level domain in this website is .com. So I'm going to give you a URL on the quiz, and you have to tell me what the top level domain is, and it'd be .com. It's easy to fall into the trap of it being over here, because you read left to right. It's not this. This is the web protocol standard. It's not this. This is just specifying www. It's the .com. The top level domain is at the end of the dots. And then after that, then we start having the folder levels and so forth. Domain name system then, which is responsible for those categories of top level domains, also deals with this. Human beings type web addresses, or URLs as we've learned they're called, such as those three. The random one in there, I'll show you why I got that in a minute. Domain name system resolves the URL into an IP address. So www.casscityschools.org is resolved into that IP address through the ping command. Now, funny thing was, they made a change to this, and I think they hid their static IP just this last month, and I've been using this for several years. I'm going to try this again today, but it's probably not going to work. Usually what I can do here with Cass City Schools is I can ping it, which stands for Packet Internet Groper. And it will resolve it to that particular IP address. I'm going to give it a shot again, but I don't think it'll work since it didn't yesterday. No, give me the same number that they had yesterday. They got some other type of IP going on, and this is like a third-party company or something that is dealing with it now. However, their static IP does still work for my sample. So if I go out to a browser, and instead of typing Cass City Schools, I type in what I've got here. Close out of this again. 98.129.143.149. .143.149, right? So I'm just typing in the IP address in my web address there instead of actually typing Cass City Schools. Enter Cass City Public Schools. Domain name system works both ways. It takes the URL, makes it an IP address, takes the IP address and makes it a URL. If they wanted to leave us human beings hanging, they could have just stuck with IP addresses and we'd have to memorize all those like a phone number to plug in the website. But luckily we have a text-based web entry that we can put in there for an address, and we don't have to worry about the numbers because it's taken care of for us in behind the scenes. So for that one part of that question about what domain name system does, be this right here, question number 11. Now that you've differentiated between an IP address and URL, domain name system resolves URLs into IP addresses and vice versa, but that's good enough if you just put that. For this class, so some of you guys are going into IT and some of you guys are not. If you're going into IT, you've got a good head start here on some networking concepts. If you're not, it's pretty cool to know how that works, I think, personally. So it's like you've seen how some of that works in the background, and now you got a bigger understanding or a bigger picture of the world. Some more World Wide Web basics. We use web languages to create web pages, and the language that Tim Berners-Lee and CERN created in 1991 is HTML, Hypertext Markup Language. It's a web language in which rules are followed for marking text with tags. That's why it's called markup. Mark text with tags so a browser can display a web page. Web pages then make up a website, this terminology. Text and files are interconnected via hyperlinks, so Berners-Lee and group came up with the concept of what we have today where you click on the hyperlink and it takes you to a website, which we've nicely used with our Word assignments and tests, where we could hyperlink out to a site. As modernity has proceeded here, HTML is a web standard from the 90s, but they've implemented better ways to display web pages and interact with databases such as XML, AJAX, active server pages. Again, we don't need to know all that for this class. What you do need to know is that HTML is a web language in which rules are followed for marking text with tags. And as an example, I like using IE for this one. It's a little bit more old-fashioned. Let's say I go to the Macomb website. That's what we see. But what's really there, if I right-click up here and I open my menu bar, I can go to some old-fashioned menus. I can go to the View tab and I can view the source code, which will then appear at the bottom of my screen. And I can actually make this window bigger. And this is Hypertext Markup Language. It actually starts the page right here with bracket, that's the tag, HTML, and it goes on, blah, blah, blah. The title of the web page, Macomb Community College Discover, Connect, Advance, which is what we see up here, is displayed because of this tag here. And the page is structured through div tags. As we go down through here, there's tags called div. As I continue to scroll down, sometimes if I want to see what's on the page, we saw some interesting stuff yesterday in class. If I get down here far enough. Aha, here we go. Right here, get ready for spring, summer, semester. That's what we see right there. So it's this little box right here, get ready for spring, summer, semester. Notice the text sizes. I find this quite interesting since you just worked with Word too. All this stuff relates, so if you learn one thing, you got a head start on the other. Notice how get ready has an H1 tag and for spring, summer, semester has an H2 tag. That stands for heading 1 and heading 2, just like you guys used in Word. Remember we clicked the heading 1 style or the heading 2 style? The same thing here, you can display text using some standard styles. And the tags start and close the entry. Just a brief example of HTML. Some simple terminology A browser is a software application used to browse the web and display web pages, and this is the first part of question 13. So, I just updated this morning, by the way, you guys. I'm proud of myself. I had an outdated stat, and I've got one as of February of 2019 up there. I actually had a hard time last year finding any good graphs, and they've got some good new ones out. I got out there and I was surprised this morning. That's one of the reasons I hadn't updated them. I was a little embarrassed with my old graphs yesterday, so I was like, you guys got to have a cleaner graph. So there you go. This is worldwide because it says global. Sometimes you'll have a graph for just the US alone. Chrome is killing everybody, right? 70.9% of the usage. Firefox is actually second. IE and Edge. To me, Microsoft is one and the same, so if you add the two together, you're somewhere right around where Firefox is, and this is the way it's been for several years now. Firefox and the Microsoft products are right in the same ballpark. Safari's not too far behind, and then you pretty much have any other browser after that. Okay, so your browser, know what that is, defined there. Bookmarks are web pages marked electronically for future reference, so I just have a picture of a book with some bookmarks there, but in reality, if I'm in
Chrome, they're referred to as favorites or starred pages.
Actually, bookmarks in Chrome, star, but favorites in IE and Edge, right? I believe. Yeah, I think in maybe Fire.
You mentioned it, yeah.
So if I go to, like, say I wanted to bookmark Cass City Public Schools that I've just gone to, I can go to that little star up there. In Chrome, and I'm going to use this in Chrome, but you can do it in any browser. It's just different in each one. You just got to find out how they do it. As soon as I click it, it says the bookmark's been added. It gives me the title of Cass City Public Schools. I can say done. Then if I go to the three-dotted ellipsis, on that I can point to my bookmarks. And it will just start adding my bookmarks here, Cass City Public Schools and so forth. And you can export these if you change computers. Like say your computer's outdated and you want to upgrade to a new computer. There are tools to export your bookmarks from the various browsers so that you don't have to redo them. It's usually pretty simple to do by just going to Google, code in something like export bookmarks from Chrome in this case. Answering the other part of 13, search engines then defined are a program tool used to search the web for specified keywords. So that's the second part of 13. For the quiz, don't get confused. We have Google Chrome, or we just refer to it as Chrome as the Google browser. But when we actually just go to Google, www.google.com, we're actually using the search engine for Google.
That is where Google had its main core, as also possibly with Yahoo. Bing is owned by Microsoft.
Correct. Google started off with the search engine, and I got to be honest with you, I went through this whole process. I'm old enough that I went through the whole process. And when I started using Google, I was just amazed at how much better search results I was getting compared to some of the old tools. And this is why they got big. They really had a good search engine built in there, and they just started commanding a lot of usage and therefore a lot of money. And they're one of the wealthiest corporations in the world now. And you can see this trend is continuing here. This is January 2010 to April 2018. Again, I grabbed this morning. Google's just cruising along at the top. Now I see a little dip right here in 18, but it's still not too significant. Bing has apparently been the culprit for grabbing a little bit, but all of those are way at the bottom.
Well, to be fair, Google is basically the universal name for when they refer to a search engine.
You Google something, right? What's that?
Just it's not owned by someone else, like group of people like working on one side.
Google people what?
Yeah, it's like certain people like around the world working on one side.
Well, the Google Corporation owns that search engine, but the people that work there are entitled to partial ownership of it because they are a part of that.
I think you're saying that
corporation.
worldwide they have different areas, companies and stuff. Yeah, it's like any big corporation now.
Exactly, that's why they're big now.
They're huge.
Yeah.
You're right. In various parts of the world.
They globalize, so that makes it a lot easier for them to market to all over the world.
And the CEO from India, actually, the Google CEO.
He's what?
He's from India.
Okay. Actually, you're right. I remember that now. I can't think of his name. Do you have it off the top of your head?
I don't know the name, like something. I don't know.
I actually had just been looking at that and reading a news article a few months ago. I remember that too.
Yeah, he was the one who like developed the Chrome, Google Chrome. So he just make it in a different level. That guy, I don't remember his name.
Yeah, his name is Sundar or something.
Yeah.
Sundar Pichai.
There you go.
Something like that.
Now, one thing I want to mention, you would almost think, why do these companies here even try anymore? They're still making millions, can you believe it, at that low level?
Well, the big reason is the idea of the search engine. While Google is the most well-known, it is not private, it's not the search engine term is not trademarked by Google. It is used by anyone who wants to make one, which is why we have things like Yahoo, Bing, Ask.com, AOL. But the reason Google is so successful is because it's been the most recognized of the bunch.
For
Bing
sure.
is one of the more recent ones.
And as I mentioned too, when I first started using it, they initially built a really good search tool. It was just so much better. I was getting way better results off the web. So that's kind of one of my opinions. I was like, I switched to Google like almost 20 years ago, like probably 2001 or something. I don't know.
Yeah,
what it was,
I've
but-
used Google a bit, but sometimes when things are on Google are a little too vague or broad, I would use Bing because it does a more refined search and gives more specific.
Okay.
deep
I actually
result.
think like they're owned by everything. When you use Google, Yahoo, still it shows like Google. Like any kind of website or anything you search, it just come out Google.
Yeah, Yahoo was
They
bought
do
out.
everything.
There's some mergers that have taken place that I haven't
Yeah,
kept
Yahoo
quite
was
up on.
bought out by Comcast
By
not that
Comcast.
long ago.
Okay. So anyways, these are the ones that are in the graph that you see there. For the most part, that's what we have here in the U.S. Is the most commonly used. The others, besides Google, are pretty low level, but Google's making billions and they're making millions, I guess, down at the bottom. There are some other search engines besides these common ones. There's one called DuckDuckGo. And I got a question mark there. It says, a search engine that doesn't track you. That's what they claim DuckDuckGo is. Google stores everything you search for sure, and they have it in a database. So some people are concerned about the tracking. The thing that I think this could be a good site. I don't know what the rules are as far as what the non-tracking is. I probably have to do more research, and then I'm not even sure I'd believe 100%. But for instance, Snapchat, if we think about Snapchat, supposedly the image is gone immediately. Well, we found that was not true because after they had claimed that, people had images that were still stored in their database too, in Snapchat. And then recently, and as actually in I think the last 2 or 3 weeks, there was some people that were planning to rob a bank, and they used Snapchat thinking they're not going to track us on Snapchat, and they actually just track them on Snapchat, and we're able to recover the data.
I'll take stupid criminals for 1,000, Alex.
Exactly. So that points out to you that whatever they say that they're not tracking you, the FBI and other agencies are going to be able to track you somehow. So there's probably a lower level of tracking here, but there's probably got to be some legalized or legal tracking because of legality purposes. I guess I didn't say that right, but because of legality, we have to track because these law enforcement companies can't just let somebody plot stuff. Is the idea nowadays? It's not a private world, no matter how much we want it to be.
Yeah, there's a little statute of the law called accessory after the fact. There was a bit when gangs were trying to commit looting sprees during Hurricane Sandy via Twitter.
Okay.
And what happened was...
I haven't heard about this one.
This was years ago. Well, what happened was there were these gangs that were planning looting sprees during the hurricane on Twitter, and law enforcement agencies were threatening lawsuits and even criminal charges against Twitter if they didn't comply with the order.
Exactly. So there's a good point that I guess you made better than I could. That these companies have to comply with what the law wants. Exactly.
Not Apple.
Not Apple?
No, I swear, because they, like, you remember when they let unlocking people iPhones?
You're right about that. They were resisting that, right?
Yeah. I'm with the right company. Shit.
There certainly are a lot of lawsuits going on. Like, there's a lot of debate now. This is actually a really hot topic. What is legal? What can they keep private? What should they not be able to keep private? Different people in different sectors have different opinions.
I feel like, man,
if
you search something, I feel like they should be able to, like, look at that, but I don't know, it's weird. Like, I mean, if it's on the cloud or whatever they call it, I feel like they should have access to that, but, if it's in my phone and you ain't got my phone, it's fun to,
I'm a little on the fence about it myself. Like, I don't know what to say on that. It's like a tough call. It's a very...
The way I see it is whenever they say that they want to look at something without probable cause, like say outside of an investigation or for say profiling, if they're just doing it to profile someone, that's a breach of privacy.
I think when they carry it to an extreme, I agree.
When it's important for safety and security of people, like say those idiots who plan the looting sprees.
True.
Then it should be something that should be handed over to the government, because what's happening is this is not just abuse of the technology, it's also in the commissioning of crimes, which would cause a lot of chaos.
That's well worded, Chris. That's well worded. I have to say.
And that's where Apple is running into a lot of these problems with government agencies, because they don't know if it's either a breach of privacy when they do these searches of suspected criminals' iPhones and Apple technologies, but the problem is, at that point, Apple is risking making themselves accessory to the fact of the crimes that are to be committed or that have already been committed.
And of course, Zuckerberg's been in the news too with Facebook, so that's a big, it's a big hot topic right now. It really is. Hot. Let me finish up this slide here on search engines. So, besides doing a regular search, an advanced search allows the user to apply filters to narrow the focus of a web search. Such as, this is a special website that Google has, not their regular search box. You go to this advanced search site they have, and there's multiple boxes here. If you're in the regular Google search box, if you put an exact word or phrase in double quotes, it'll look for that specific phrase. It's called explicit. If you put two words separated by or, it's more likely to look for both words. and not, look for both words separately, I should say, rather than each individually. So you can customize your search to get better results. Yes, just typing it in is going to give you pretty good results because they have it designed for that.
Well, the main idea for these advanced search tools is there's a lot of information out there, but if you're looking for something very specific, you want to use whatever tools you can to narrow it down.
Yeah, if you're into like research and stuff, for instance, you can actually search a website for a phrase and then specify that you want it in a PDF file, which might mean it's a document on a government website or something that's very important. You can also specify usage rights. I want to give an example of this with a sports player. Okay, so I go to Google, and I search for,
LeBron James?
we could try LeBron James, sure, let's try him. I got really good results with a couple other players locally here, both basketball and hockey earlier, but let's try LeBron. Okay, so I go to LeBron James and I want to look at images for him. So instead of going to the websites, there's an option in Google here for just images, so I can click that. And then maybe I want to see like an individual image of him, so I can click on one. Like there's his new Lakers uniform. So I could right click and I can say save the image as. And I got a great picture of LeBron. But let's go back for a second and try the advanced search. So under Google here, I'm going to put in advanced search, enter. Because Google has its own advanced search, it's the first thing that comes up here, google.com/advanced_search. So I'm going to click that, and there's that set of boxes that I had on your slide presentation. Now if I put LeBron James right there in all these words and click advanced search, I'm not going to get anything different because I haven't really changed anything. But if I look at some of these other boxes here, one of them at the bottom specifies usage rights. So I'm going to put LeBron in here again. And then I'm going to go down here to the usage rights. And instead of not changing anything, which means not filtered by license, I want to try free to use, share, or modify. Let's try that one. I'm actually going to go down to this last one, even commercially. That's the most restrictive. And I'm going to say advanced search. And then I'm going to click images. And it's kind of apparent on this one too. What do you notice about the images compared to the others?
They're all calves.
They're all calves and they're not as good. They're older images and they were taken more by amateurs rather than by professionals. So if it's marked as free to use, share, or modify, it's pretty much like, hey, you got pretty much a free reign at this. You still have to be careful. That's a pretty decent picture there. You still have to be careful to credit the source, but you're in a lot less trouble if you were to use this on a site rather than if you use one of those other really good ones and you don't specify the author. So I just want to make sure everybody understands usage rights. It's kind of like plagiarism when you're writing a paper. So if you're getting stuff electronically off the web, make sure you use a tool like this. All right, so we will resume this lecture next
Thursday?
Tuesday.
Okay.
Thursday we're going to do
Thursday's a lab.
as a lab. The lab on Thursday is pretty complex. I usually can finish it, but every once in a while we can't. So if we can't, we would continue that Tuesday before we finish this. But either way, Tuesday is going to be a day to wrap up some loose ends. I hope you guys are safe in the snow we're supposed to get tomorrow, and that you have a great day.
Good luck with today's lesson.